So what I'm going to do now is change the times per division so that we can get and see that inductive ring down at the second or the trailing edge of that spike. Okay, see that? That's a nice inductive ring down. Now we'll go up and do the same thing for the fluke. We're going to look at this portion of that spike. Okay. There we go. Okay. So that's the inductive ring down now. That's that little spiky portion there. And you can see that once in a while the trace actually jumps a little from left to right. See there? That's one of those false triggers, okay, caused by that weird shape on the pulse there. So now I'm going to move the trigger again to get to a point where the signal is not actually triggering the scope very well. See there, the signal kind of disappeared because the trigger is not picking it up. So we'll move the trigger up a little bit. Move it up some more. There you go. Okay, so there's that signal. That's the inductive ring down. And if we get into a portion where the ring itself is a little erratic, like right there, you can see that the fluke doesn't stabilize on the time base very well there. See how it's jumping left and right? And as I vary the amplitude of the signal, I can do that by going to the gain control here, right? That's that series pot from the signal. As I vary the amplitude of the signal, that oscillation can go away, or it can move, or it can get this, what did she call it? The random Hartley resonance or something like that? Yeah. Okay. This is a phenomenon that's called false triggering. It's fairly common with spiky signals. The LaCroix is less subject to false triggering. The triggering just drops out, but if it gets a signal that's reasonable at all, it'll resolve that fairly well. Okay. Now I'm going to show you what happens when you switch MOSFETs. We've been running on the IRF PG50 all this time. Okay, so now what I'm going to do is I'm going to switch to the other MOSFET. Oh, I'm sorry, we haven't been. We've been running on the 2SK1548. The switch is to the left. So all of this has been with the 2SK1548. What I'm going to do now is switch to the IRF PG50 MOSFET with the slide switch, and you can watch this inductive pulse here going. It almost goes away. That's because the IRF PG50 is switching more slowly and doesn't create a lot of that spikiness. Let me see if I can even catch that. So we'll go back to the 2SK1548. I'll turn the time per division back down so we have multiple pulses displayed there. Okay. And this indicates the 0 level, so we have a DC offset just as before. That's the battery voltage up there. That's the trigger level, so I'm triggering on the peak of that little pulse right there. And if I try to trick it by moving the trigger, there we go. There's your aperiodic Hartley oscillation. What the hell? Okay, so let's get back up to where we're triggering correctly, which is going to be right there. And then let's switch MOSFETs. Now we'll go to the IRF 15, or rather the IRF PG50 point. There you go. See how those spikes just go almost completely away? And you can get them back, of course, by changing your voltage per division. But that also puts the offset up, since we're looking at DC coupling on this trace right now. Okay. coupling. See there, we're at DC 1 mega ohm coupling. Watch what happens, and so when I change the volts per division to try to amplify that spike, the trace goes up and up and up because of that DC coupling. Now if I go to AC coupling, and now we're AC 1 mega ohm, I can change the volts per division, and the scope removes the DC offset, and the trace stays where it is. The trigger level went up though, so I got to turn the trigger down. Here it comes. There we go. Okay. So now we're scoping this signal at AC coupling, and we have to rely on the scope's parameters to tell us what they are here. Okay. All right, so now that we've got a trace, let's look at the ring down portion. And look at that, that's very different. But that's the, no, that is the lead, the trailing pulse there. Okay, so that's the trailing pulse. Let me move it over a little bit so it's in the middle here. Okay, change the trigger delay. Okay, that's the pulse on the trailing edge from that MOSFET, and that's the pulse on the trailing edge from the 2SK MOSFET. And do you see that? You see that random Hartley oscillation there? That's false triggering of the oscilloscope. Okay, and there's the other MOSFET. That's the IRF PG50. It doesn't switch as fast, so it doesn't give you those nice spikes like that you get from the 2SK. That was a long video.